Good day, welcome back to my channel, and today we'll be looking at a circle theorem past paper question from June 2022. So it reads, H, J, K, and L along with M are points on the circumference of a circle with center O. MK is a diameter, as you see here, of the circle and is parallel to HJ, right? As you see right here. And it says MJ is equal to JL, and angle JMK is equal to 38 degrees. So whenever they ask you to find an angle, they're always referring to the middle letter, right? So where it says that JMK is equal to 38 degrees, if you realize the angle is at the middle letter M. So now let's find out what they want us to find first, right? So they said explain giving a reason why angle HJM is equal to 38 degrees, angle MJK is equal to 90 degrees, and also they want us to determine the value of each of the following angles and show detailed working where appropriate. So they want us to find angle MLJ, angle LJK, and angle JHM. So let us go to the question, right? In circle theorem, it's best to find the angles first before actually looking for what the question asks for, because sometimes when you find the angles before, right, um you'll already have the sometimes you might realize that you have the answer on hand, so you don't really have to go back to the starting point. So before they're asking for a reason, so they say explain giving a reason why angle HJM is equal to 38 degrees. So let's look where HJM is. HJM, they're speaking of this angle and they want to know why is it equal to 38 degrees. If you realize, this actually forms a Z angle, right? And we call Z angles alternating angles, right? And what do we know about alternating angles? They are equal. So if this angle here is 38 degrees, this angle here is 38 degrees as they mentioned. So the reason why this angle is 38 degrees is because they're alternating angles are equal. So now the other question is they want to know why MJK is 90 degrees. And MJK refers to the entire angle here. See? MJK. So it's simple. We know that there's a theorem which says angles in a semicircle, the angle in a semicircle, which is this, right? This one is 90 degrees. So it's 90 because it's an angle in the semicircle, right? So bear in mind the entire angle here is 90 degrees. But I'm not going to write the 90 degrees here because if you realize this angle is separated, right? It's separated in a sense as you see the line which draws through here. So this means that this makes up a degree out of 90 along with the other one. So we can just make note from here that this is 90 degrees. But like when we're solving, most times they're going to ask you, for example, probably if they wanted to find MJL, they probably want to know what this angle is equal to out of 90. So let us proceed, right? So we just didn't do that to cause any more confusion. Just have a 90. So just to let you guys know it's equal to it as they said too. So now they want us to determine some angles. So before, what we can do is to solve for the angles before we look for the ones they ask us to find. So it's best to find all of the angles first. So if we can find what this angle is, you know why? Because if we are to examine this entire triangle, right, we know that this angle here, the total angle here, is equal to 90 degrees, right, in this triangle entirely, along with 38 degrees. So we know this angle here is 90 degrees, this one here is 38. And what do we know about the angles inside of a triangle? They all add up to 180 degrees. So to find what this angle here is, all we can do is add 90 to 38, right? And we get 128 degrees. And then we take that 128 degrees from 180, and then we get 52 degrees. Therefore, this angle is equal to 52 degrees. All right, so let's move on, right? Note that we can also find this angle here because there's another theorem. Angles in a segment are angles in the same segment are equal. So if you look, it forms that. So if this angle here is 52 degrees, this one here is also 52 degrees, right? Yes. So let's see if we can find another angle. We can find this little piece here, right? Because remember in the example here, when it says MJ, MJ is equal to JL. MJ is here, right? It's equal to JL. If you realize it forms a triangle, so being that it says it's equal, we realize that the base angles is actually an isosceles triangle. If you see the little strokes it have here, right? So being that it's an isosceles triangle, it is saying this angle here, which is 52 degrees, is equal to this angle here. So now we know the total angle here is 52 degrees, right? But out of 52, this piece here is 38. So to find the remaining of angle, which is right here, right? All we need to do is to take 38 from 52, which leaves us with 14 degrees. So we know, right, this angle here is 14 degrees. This is a piece here. So now, right, we could also find this angle here. Remember earlier when I said that I'm not going to write the 90 in this angle because these pieces are separated and this makes up a piece out of 90. That is where I'm going to explain on more, because if you realize, we can also find this angle here as a piece out of 90, because guess what, we already established that this is an isosceles triangle and both base angles which are equal are 52 degrees, right? So we can find what this piece is equal to. So all we need to do is to add 52 plus 52 is 104, gives you 104 degrees, right? So now to find what this angle is, we know angles in a triangle add up to 180. So if you take 104 from 180 degrees, you get 76. So this makes up 76 degrees out of 90. So now, right, we can also do this. We can find what this angle here is, right? Because we know the total angle in this semicircle, right, is 90 degrees. So this makes up 76 out of 90. So what we can do is to also take 76 from 90 to find this angle here, right? And therefore, if you take 76 from 90, you're left with 14 degrees. So we also found this angle here, right? So the 76 plus the 14 adds up to this 90 degrees. All right. And also, right, we can find another angle because there's this theorem. Opposite angles in a cyclic quadrilateral are supplementary, or let me rephrase it. Opposite angles in a cyclic quadrilateral adds up to 180 degrees. So we know that angle MLJ is 52 degrees, right? So now, being that is opposite to MHJ, we know that, all right, at H, right? It has to be supplement, it has to add up to 180. So now 52 plus what give you 180, right? So it'll be 180 minus 52. So this means that this angle here is 128 degrees, right? So we found that. So if you add these two up, you get back 180. So finally, let's see if we can find this angle here. Again, we realize that MHJ is a triangle. And we know the rule, angles in a triangle add up to 180. So all we need to do is to add 128 along with 38, and we get 166 degrees. Take 166 from 180 and you get 14 degrees. So being that we found all of our angles, right? We can now look for what the question solve and put reasoning, because with circle theorem, finding the answers are one, right? But you need to find a reason. And the first question was to find angle MLJ. Let's see if I accomplish that. ML, let me see. MLJ. Yes. This angle here, right? So they asked us to find MLJ, and we did. And we said that MLJ was equal to 52 degrees, right? And the reason for that is because angles in the same segments are equal. If you see, yes. So MLJ equals to 52 degrees because angles in the same segments are equal. Now let's look for the other angle they ask us to solve for. LJK. Let's look if you see it. LJK. All right. LJK, right, is 14 degrees. Remember, it is the angle in the middle, it's a right. And the reason for that, for angle LJK to be 14 degrees is because we can use the same theorem. Angles in a semicircle as up to 90 degrees, right? So 90 minus 76, 90 degrees minus 76 degrees leaves you with 14 degrees. And finally, they want us to find angle JHM. JHM. And JHM is equal to 128 degrees. And the reason for that is opposite angles in a cyclic quadrilateral are supplementary, are opposite angles in a cyclic quadrilateral adds up to 180 degrees. So that's it basically for the circle theorem past paper question. I hope you learned something new, and remember to like, share, subscribe, and I will definitely see you next time.